Hello, this is Mr. Collier, and today we're doing equations reducible to quadratics. Basically, they can be written as quadratics. So this one here looks like it is a quadratic in x squared. So you can write it like this. If you want to see it clearly, you can do let y equals x squared, and then convert this to a quadratic. Okay, so this becomes y minus 4, y minus 1, but put back in the x. So y equals x squared. So we get x squared minus 4 equals 0, x squared minus 1 equals 0. So x equals actually positive negative root 4, which is positive negative 2. And here we got x equals positive negative 1. So it's 4 solutions there. The second one, it looks like a quadratic as well, but you would let y equal this whole thing, but it's to the power 4, so squared. So then you got y squared plus y minus 6 equals 0, y plus 3, y minus 2 equals 0. So we have y equals negative 3 or y equals 2, and then just we'll plug in what this is now. Okay, we get 2x minus 1 squared equals 2. So this one's impossible. You can't square root a negative number. So let's go ahead and do this one. We have 2x minus 1 equals positive negative root 2. 2x equals 1 plus or minus root 2. So x equals 1 plus or minus root 2 over 2. Okay, next let's try this one here. Well, obviously this is going to be 3x squared. So we have, maybe let y equal 3 to the x. We got y squared minus 10y plus 9 equals 0. Y minus 9, y minus 1 equals 0. So we have, let's plug back in 3 to the x now. 3 to the x equals 9, 3 to the x equals 1, and that is x equals 2 or 1. Okay, the next one we have a bit of a typo, so let me just change that to a plus. Okay. Now, we want to get rid of the square roots. We're going to have to square it eventually, but it's easier if you isolate the roots like this. And square both sides. We've got 2x minus 5 equals, we've got to square this whole thing, so we're going to get 1 plus 2 root x plus 1 plus x plus 1, this part squared. Okay, let's keep this root on the right and then get everything else to the left here. So let's subtract x from both sides. We get x, and then we get minus 7 equals 2 root x plus 1. Now we can square both sides. X squared minus 14x plus 49 equals 4 times x plus 1. So x squared, let's minus 4x from both sides. Minus 4, and then we got 45. Then we got x minus 3x. Wait, is that right? Sorry, that's supposed to be 45. And this factorizes to x minus 3, x minus 15. X equals 3, x equals 15 are possible solutions, but you gotta be careful with square root equations. Sometimes these don't work in the original equation. Okay, so actually if you plug them both in, it looks like it works, like you don't get square root of a negative number, but actually one of these doesn't work. If you plug in 3, let's see what happens. Root 2 times 3 minus 5 minus root 3 plus 1. That equals, what is this, 6 is root 1 minus root 4. That actually equals negative 1, right? So actually this one here doesn't work. If you plug in 15, it does work, right? Okay, so that's a false solution or extraneous solution. Right, so you do have to plug it in and actually check it.